Okay, they want us to differentiate this problem over here. It's not a difficult differentiation problem, but what I wanted to show you was that the three techniques that we've described so far are going to basically lead to the same answer. It certainly requires work, though. Certainly some techniques are easier than others, but they're all going to lead to the same answer. All right? So the first technique is just going back to what you did in the beginning of the class, which kind of using the rules of differentiation. So the first thing I would do is rewrite this as a power, because powers are pretty easy to do. And this would be x minus 1 over x4 plus 1 to the 1/2 power. Before I proceed forward, I want to point out the domain of the problem. Again, the real number system, the x would have to be greater than or equal to 0. So the domain is 1 to infinity. Now, there's certainly going to be an issue with the derivative, because the derivative's not going to be defined at 1. All right, so let's take a look at this and see if we can get the derivative down. And again, if you're just writing the derivative down, it's fairly easy to do, by the way. And let me write that down. So I'm going to write down y prime. Well, I'm using the power rule, so 1/2 comes down, and then it's going to be minus 1/2. And what's the argument there? It's x minus 1 over x4 plus 1, all right, times the derivative of the inside. Well, I'm going to use the quotient rule now. That's going to be x4 plus 1 squared. Bring the bottom to the top. That's x4 plus 1 times the derivative of the top, which is 1, minus the top, x minus 1, times the derivative of the bottom, which is 4x cubed. Now, for a lot of students, they're done there, and they put a box on it, like this over here. A lot of teachers also like it written this way because it's easier for them to grade. All right, let's take a look at it, see if we got that part. And I'm seeing this. 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 Let's see, I'm seeing this. It's certainly a different order of the multiplication, but still x minus 1 times x 4x cubed. Still the same thing. So what I got to do is over here, I always say that, a lot of times teachers stop there and they don't bother with any simplifications, or if they do, the students glaze over. But my goal is to simplify it, all right? So the first thing I would do, let me remember race track, because I met my first goal. And meeting your first goal is great, but I'll be honest with you, it's not a very high bar at this point, right? So meeting this goal over here is great, but I want to go the next step. And someone says, I wonder what the next step is. The couple of things I would do is just simply rewrite that negative power, right? As you see the negative 1/2. And I would say it's just simply 1/2. And then I would write a root down. And in negative power, so it's going to be x4 plus 1 over x minus 1. Not a big issue. What do you get on bottom? You get x4 plus 1 squared. Again, not a big issue, by the way. What do you get on top? Let's see. I guess you could just get x4 plus 1 minus 4x4 and then plus 4x cubed. And I would continue to factor that. And I shouldn't say factor it, simplifying it. And I think that top looks fairly simple to do. So let me just write down what the top appears to me. Again, I'll erase and write it down in a second. So it looks like minus 3x4. And then what would you get? Let's see. I think I made a mistake somewhere. No, I didn't make a mistake. Plus 4x cubed. I'm just clipping things off, by the way, and plus 1. I don't like the leading coefficient of minus 3 there, so I'm going to factor it out. And that would be minus 1 times 3x4 minus 4x cubed minus 1. I'm going to get my eraser out. I'm going to erase this business over here. And I'm going to put down the minus here. And then I can put the 3x4 minus 4x cubed minus 1. I want to see if I met that goal, right? Do I see the minus 1/2? Yep, right here. Whoops, sorry about that. I see it here. I'm seeing it. Do I see this? Yeah, I see it. Do I see this? I do. Do I see this? I do. So things are looking good. All right, now someone's going to say, I wonder what you did next. I wouldn't have done that, to be honest with you. So I'm going to erase this over here. And if this was me on the exam, what I'd be boxing now, after all my work, I'd put a box right over here. I would say it's about as easy as it gets. All right. Now, sometimes you can rationalize the denominator, things like that. It really doesn't add much to it. But I say it looks pretty simple form of it. I can analyze it now. Certainly I know the derivative is defined for all x greater than 1. Doesn't include 1, by the way, except division by 0. Certainly there's some issues over here, like that fourth degree polynomial on top, trying to solve that, yada, 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 if I want to do min-maxes and stuff like that, increasing, decreasing. Right, so we'll hold off on this part over here. And someone says, I don't even know why that's written down. It's for a reason, by the way, but we'll hold off on that. The next thing I'll do is I want to use logarithmic differentiation. That's what this section's about over here. You take the log of both sides, relatively simple to do. And when you do that, what do you get? You get the natural log of y equals, well, I'm going to write this, you realize that root symbol's really just a half power. So I'm going to bring the half power down using rules of logs. Then you get the natural log of a quotient. These are all things you learned in Math 119, by the way. And then I can write the natural log of y is 1/2 the natural log of x minus 1 plus, not plus, it's a minus because I'm dividing, right? So let's put this down again, get it right. It's minus 1/2 the natural log of x4 plus 1. I want to make sure I've met that milestone. I'm seeing the natural log of y. I'm seeing this. And I'm seeing this over here. And differentiating this, it just couldn't get any easier. Right, what do you get? Well, let's differentiate. You would get 1 over y, 1 over y dy dx equals, well, this was pretty easy. It's 1/2 times 1 over x minus 1 minus 1/2, and that would be x4 plus 1, chain rule, that would be 4x cubed. And again, a lot of teachers would simply say, oh, what's dy dx? Let's write this down. It's equal to y. I'm going to pull out the half by y over 2, and then I get 1 over x minus 1 minus 4x cubed over x4 plus 1. All right? Now, again, a lot of teachers would just stop there. They'd say, this is a good answer. I want to write down what the y is now. So let's put this down. So dy dx, well, the y is this thing over here, so I could write this down. So it's 1/2. The y is this, which is x minus 1, the root of, and then it's x4 plus 1. And I want to do what's on the inside over there, and that's x minus 1, x4 plus 1. And let's see if I can do that inside now. Well, let's see, that's x4 plus 1 minus 4x4 plus 4x cubed. I'm going to continue to simplify that. And I'm really in the same situation over there. I realize I've got a leading coefficient of a negative number, so I'm going to factor it out. I get this. And then I get this. You know what? That doesn't look right. Let me erase that again. x4 plus 1. And on top, you're going to get what? Let's just make sure we're careful about that. It's minus 3x. I'm sorry, I made a mistake in that notation too, didn't I? It's minus 3x to the fourth, but I factored out a minus 1, so it's 3x to the fourth. I factored the minus 1, so minus 4x cubed minus 1. All right, let me show you where that's written. And that's written right over here. So I see this. I see this. I see this. And I see this. Certainly I'm noticing things now. I'm noticing they're different. Right? These two are different now. Not greatly so, but they are different. I mean, I'm looking at this, and I'm looking at this, and I see them as being different. So what I want to do is I want to go back to the other one. I want to see, why are they different? Why do they look so different? And we're going to just, carefully talk about what I did next. Because I'm saying, did I make a mistake somewhere? Am I misunderstanding something? Because they should look the same. So let's go through it, and I want to see if I get it to look like the other guy. All right? So what I did over here is I looked at this guy over here, and by the way, I'm looking, again, I want to point out, I'm looking at this over here, and I start to realize I got to do something with it. And, some of the things I could do with that is look at it. And again, this is my goal. This is a goal. I want to get this to look like my goal. And so what I did, I want to point out to you, that seems strange to you, I wrote that down as a square twice. And then I put these missing factors in, x minus 1 over x minus 1 is 1. So I haven't changed it, all right? Have not changed it. Now what I want to do is I want to just carefully go through what I do say. I definitely see, I'm going to start to erase these things here. Erase this over here. It's what I do say. What I do say. I see this in both cases, and I see this in both cases. Oops, sorry about that. Let me go. I'm looking at the answer. Let me get that erased right again. Let me erase all this business over here. Again, I want to point out what we're looking at. We're looking at this. We're looking at this. And I want to say what I do have. I definitely have this. I have this. But the other things are looking different. And that's where I'm the rewriting thing. And again, my goal is to get one to look like the other. All right? So what I did again was I kind of, I'm looking at the bottom over here and I realized there's, a factor of x minus 1 and a factor of x plus 4. So I wanted to make sure I saw that part. All right? And, doing that, I want to point out what is written next to it. It's the same thing that's what's above it. And then I got to start figuring this out. All right? Can I get that? Right? So I'm getting everything I need. I'm getting this. I'm getting this. I'm getting these two things over here. And I'm wondering if, let me use a different color. I'm wondering if all this business over here, if all this business over here leads to what they say it should be. All right? What they say it should be this thing over here. Let's see if it leads to that. All right? And I don't know. Let's take a look at that. Let's write it down, and I'll write it down. So it's going to be, the root of x4 plus 1 over x minus 1, and then I get x minus 1, and then I got x4 plus 1. Well, these don't look too bad to do. I'll say power 1, and what would you get over there? Well, looking at just roots and rules of exponents, what would I get? Well, on the bottom, I would get the root of the root of x4 plus 1. I'm simplifying these two. And this guy over here, what would I get? Well, let's see, I'd get to the root of x minus 1, which is what I wanted to do. And I'm seeing that right over there. So it's good I looked at that and I said, these really are equivalent. All right, I went through the work to show that. All right, so we've used two methods so far. What methods have we used? What we've done in the beginning of the class, right? We basically use, the power rule, quotient rule, and we did get to the answer. I also use logarithmic differentiation, and I'm getting to the same exact answer, by the way. And there's a third method, and the third method I want to go through is what's called implicit differentiation, stuff we've covered prior. And it's got to lead to the same answer, by the way. It has to. So the way I did this over here is I broke it up, right? And the way to do that is, maybe multiply both sides by the LCD. And let's write this down now. And what would you get? Well, the LCD would be the root of x4 plus 1. So you get y times x4 plus 1 to the 1/2 power equals x minus 1 to the 1/2. And that's written right over here. And then I would just do a straightforward differentiation. All right, let's go through that. That's going to be implicit. So I'm going to say the right side is really easy to do. And the right side is going to be 1/2 times x minus 1 to the minus 1/2. The left side is more complicated. And let me write this down. So it's going to be y prime times x4 plus 1 to the 1/2 plus, I can't fit that in there, can I? Let me write it below it. It's going to be y times a derivative. I'm using the product rule, by the way. Well, it's going to be 1/2. And then you're going to get x4 plus 1 to the minus 1/2 times the root of the inside, which is 4x cubed. All right? Let me show you where that's written. And that's written right over here. So again, y prime. I get this part over here. Got the plus sign. Let's see, did I get this? 4x cubed y. I do. Over 2. And then I got this business over here. Did I get the right side? Yeah, I got the half, and I got this over here. So I'm pretty clear that that's not a bad thing to be doing over here. I'm going to start to erase things because I feel comfortable I got to that stage. I'm getting to the stage I want to get to. Now, certainly, a lot of teachers would say, oh, you're done now. You're not done. You have to solve for y prime. All right? So if I solve for y prime, I guess some things I could do, I think I'm going to multiply both sides by 2. And you would get 2y prime x4 plus 1 to the 1/2 plus 4x cubed y x4 plus 1 to the minus 1/2. And that's the left side. And if you multiply the right side by 2, you get x minus 1 to the minus 1/2 power. And I'm going to make an attempt to solve for y prime now. And the way to do that is I'm going to do it in pieces. It's really 2y prime x4 plus 1 to the 1/2 would equal, well, it's going to equal x minus 1 to the minus 1/2 minus 4x cubed y x4 plus 1 to the minus 1/2. And now I got to divide both sides by the coefficient of y prime. Let me write that down for you. And y prime is going to equal x minus 1 to the minus 1/2 minus 4x cubed y x4 plus 1 to the minus 1/2 divide by 2 x4 plus 1 to the 1/2 power. All right? I got troubles. Looking at it, it looks really kind of crazy looking to me. I mean, there's a y in it. I got these things all over the place. I mean, I'm gonna try to simplify a tiny little bit because I do want to match the answer, by the way. So again, we're looking at this, and I want to simplify a tiny little bit. One thing I'm going to do, I just kind of factor out the bottom part, and you'd get, let's see, 1. You would get a 2. You would get x4 plus 1 to the 1/2 power. And let me do that inside now, which looks really kind of crazy to me. Well, it's going to be, let's see, x minus 1 to the minus 1/2 minus 4x cubed. What's the y? This is the y. Let me write that down. It's going to be the root of x minus 1 over x4 plus 1 times, well, x4 plus 1 to the minus 1/2. All right, let me show you where that's written. And that's written right over here. I see that. I see this. I see this. I see this business here. And I see this business over here. And I'll be honest with you, that's where most teachers would stop. They'd say, this is the end of it. Right? So I'm going to erase this business over here. I'm pretty much done with that. I'm pretty much convinced I got there. And it's not a bad place to stop. However, I'm wondering, did I make a mistake somewhere? It's really the same thing as I say it's supposed to be, which is this thing over here. Is it the same thing as this? All right? I don't know. Right? I don't have the same thing. So what I want to do is I want to go through it. How would you do it? And I want to point out, I'm kind of looking at this, and I know what my goal is, but to get there, I got to do some things, right? So the one thing I did, which might seem strange to you, I factored out something that I wanted. And someone says, what do you want? I really want the x minus 1 to the 1/2 power. So I needed to factor that out from somewhere, and I factored it out from here. So I want to point out what I'm factoring out. I'm factoring out x minus 1 to the 1/2 power. That's all I'm factoring out. all right? So if you do that, I get the bottom still, right? That's not changing, and I factor this out. Now, if you factor this out from the first term, let me get my eraser out now, and I want to point out I'm factoring that x minus 1/2 power out from the first term. And what would you get there? Well, x minus 1/1/2, well, the power would have to be minus 1 now, because when you add those two together, it'd give you minus 1/2. Right? Now, what do you get on the other one? Well, you get this. That's still going to be there. You get this. That's still going to be there. You get this. That's still going to be there. And this comes out. All right, but I'm at a loss now. I'm looking at this, and I'm wondering where that came from. Well, let's go through it. All right, so I got this over here. I got x4 plus 1 to the minus 1/2 over x4 plus 1 to the 1/2. Well, that's easy. It's just rules of exponents. Minus 1/2 minus 1/2 would be minus 1. So I'm seeing that. All right? So I'm pretty clear that I was able to get to this stage over here. Right? I'm going to outline where pretty clear we got to. I got this, and I got this over here. But the question is, again, I'm looking at this, and I'm looking at the other one. What if I do the same thing? Well, I definitely did get something here, and I want to point out what I got. I definitely got a root. I got 1/2, the root, and I'll circle this to make sure you know what I'm looking at. Let me get my eraser out, and I want to point out I definitely got this part. All right? Now I got to do the inside. Let's write it down. And what do you get? You get 1 over x minus 1 minus 4x cubed over x4 plus 1. Well, LCD, I'll write this down for you. That would be x minus 1, and then you'd have x4 plus 1. Well, that's x4 plus 1. That doesn't look right. Let me erase that, try to do it a little bit neater. It's x4 plus 1 minus 4x cubed times x, which is minus 4x4, and then minus 4x cubed times minus 1, which is plus 4x cubed. Well, I'm seeing what I want to see. And what am I seeing? Minus 3x to the 4th power plus 4x cubed plus 1, but I'm going to factor a minus 1 out, and I'll put this over here. What am I left off with? Common denominator, x minus 1, x4 plus 1. What goes in the numerator? Well, remember, I factored out the minus 1, so it's going to be 3x to the 4 minus 4x cubed minus 1. Now, again, I realize people saying, I wonder if that's what I wanted. It's what we want. We got this. We got this root problem over here. We got this part. And we got this part. So each one leads to the same thing. They all lead to the same thing, all right? Now, granted, you might say, I want to write them differently. You can. For example, a lot of teachers, what they would enforce is you can't have a radical on the bottom. I don't think it really adds much to it, but if you wanted to, you could take each of these over here now and multiply it by this. And then you would rationalize the bottom there. Does it add much to the problem? In my opinion, no. If you did it, though, what would you get? You would get minus 1/2. Let's be careful here. What do you get on bottom? Well, let's see. You get x minus 1. Then you get x4 plus 1. There would be actually 2 factors of that now. I'll put this over here. What do you get in the numerator? Well, a little complicated. You get this over here. You get the root of x minus 1 times x4 plus 1 times that polynomial, 3x4 minus 4x cubed minus 1. And I would say that, for a lot of students, that's what some teachers would actually get to that level. I just don't think it's important. All I want to do is say that each one we get leads to the same answer. No surprise there. Thank you so much for paying attention.